Hello children, welcome to Vidyalakshmi YouTube channel. This is your Shaktivel Max teacher. Today we are going to continue chapter number 1, relation and function. In the last video we have seen what is the empty relation, what is the universal relation, what is the trivial relation, and followed that what is the equivalence. Equivalence means what is reflexive, what is the symmetric, and what is transitive. All those things we have seen in the definition with the examples. If you have not seen that, kindly you see the video, then you come back to the part 2. This is part 2, continuation of the part 1. Okay, right. In part 2, what we are going to see, based on the equivalence relation definitions, textbook, NCERT textbook examples, we are going to continue. Okay, so this is textbook sums only, NCERT textbook sums. So NCERT textbook sums only I am going to take. Right, now example 2, what is given, we'll see. T be the set of all triangle. T means what they said, set of all triangle is the T. So that here you write T is equal to set of all triangles. Okay, set of all triangle is the T. Next, what is that? This is in a plane. Okay, with relation R, T is given by some condition. R is given by some condition. What is R is given? That we will see. R is equal to, they given that T1 means triangle 1, triangle 2. See, they making pair. Relation means collection of ordered pair, right? That is what they are writing in the ordered pair. Okay, right. Actually, one more thing you want to know. Relation will be subset of a Cartesian product. Okay, will be subset of Cartesian product. So Cartesian product will be formed what? Set of ordered pair. All the relations they will be writing, so that only relation also will be coming in the ordered pair. Understand? Right. Now here, what is that? T1 comma T2 such that T1 is concurrent. T1 is concurrent to T2. T1 is concurrent to T2, they are telling. Both are concurrent, it seems. Concurrent means, have you remember children, we have seen in what is the 10th standard and 11th standard. Concurrent in the sense, any figure, either triangle or quadrilateral, whatever, any figure should have same shape and same size is called the concurrent. Same shape and same size is called the concurrent. Understand? Right. So here, so they given condition, triangle 1, triangle 2 is a concurrent, then only it will be term of relation R. Two triangle if we take, it will be concurrent, then only it is the term of R. That is the question, it's a given. Okay, what they asked to show us, R is the equivalence relation. Equivalence in the sense what I said, it should be satisfied reflexive, and it should be satisfied symmetric, and it should be satisfied transitive. All the three conditions will be satisfied. Then only we can say what is that? Equivalence relation. One by one we will check all the three is satisfying or not. Okay, right. First I will take a reflexive. Reflexive in the sense, what is the definition? See children, you go with the definition. Definition you write. Means what is the reflexive condition that you write, then you enter in the answer. Suppose your answer, it should not be wrong. Suppose wrong, you will be getting step mark. It will be provided the step mark. So a safer side you should go. Understand? But some people will be scoring full mark. Those who scoring full mark, they will be checking all the thing, even formula, whether they have written, answer properly is there, what, everything they will be checking, so that it should be proper manner. So that reflex in the sense, generally it should be A comma A belongs to R for all A belongs to the A. Okay, where A in the sense what here? T for us in this question, A means T, set of all triangle. Small a will be T1, T2 here. Understand? This is formula, so I wrote as it is. But in the sums, when you enter, you want to use T1, T2 like that. Right. Here, suppose if you are taking, suppose later if condition, you will go. If I am taking triangle 1, The triangle 1 is concurrent to triangle 1, surely. Then it will be blank star. Sir, how is a triangle 1, what is that concurrent to triangle 1? It means if you taking one triangle 1 you are taking. Triangle 1 if you take, it has a side, for example, 2, equilateral triangle I am telling. All the sides are 2. Then one more triangle I am taking, that is also triangle 1. It is triangle 1 in the sense, this is also should be contained same side, it never change. Am I right? So what I said, concurrent in the sense, it should have same shape, same size. Size means it should not change the length and all. Okay. Then surely it will be what? Concurrent. That is what every triangle is concurrent to itself. That statement you should write. This diagram only for understanding purpose. Okay, children. So you want to write here, since every triangle is concurrent to itself. That you can write. Okay. What you can write? Concurrent to itself you can write. Concurrent to itself. Have you understand? That you can write. Since every triangle concurrent to itself, so we are telling T1, T1 belongs to R. If it is satisfied, what we can say? Therefore, T is what, Raja? Then therefore T is what? Reflexive. T is what? Reflexive. That's it. Okay. T is what? Reflexive. Okay. Next topic, what will go? After the reflexive, symmetric you should check. Okay. Symmetric. So second, what will take? Symmetric. Symmetric condition, what you must know, children? Symmetric condition, what you must know. Okay. Symmetric condition is what? If two term A1, A2 if belongs to R, this implies if you are taking one pair in the relation R, their reverse part also should be there in R. That is, we have seen with the example in the previous video. If you don't have about idea this, kindly you see the video, children. Kindly you see the video, then you will be getting idea. Here for all A1, A2 belongs to the A, set A. Kindly you see the previous video, then you come to this example, you will understand very easily. Understand? Right. Now let's check this first. Instead of A1, A2, we have to use what here? Triangle 1 and triangle 2. Don't forget. Okay. So we'll go now. So first of all, we'll take if condition was first two things should be belongs to R. That I am taking. Then T1, T2 belongs to R. Belongs to R we are taking. Okay. If it is belongs to R, what is the meaning of the belongs to R? What condition it will satisfy, then it belongs to R. If it is satisfy concurrent to rule, then only it will be belongs to R. Otherwise it is not. Understand? Right. Then if it is belongs to R, what is meaning of this? Triangle 1 is concurrent to triangle 2 is a meaning. Have you understand? T1, T2 belongs to R, it meaning that T1 concurrent to T2 is a meaning. Understand? So that this what we can say, children, triangle 1 concurrent to triangle 2, then surely triangle 2 also concurrent to triangle 1. Am I right? What it mean? If I have a triangle 1, I have a triangle 1, I have a triangle 2. Okay, I have a triangle 2. It should be same size. Just a minute. Just for example, this is. Okay, I have a triangle 1. I have a triangle 2. So, triangle 1 I have side 2, 3, 4 na. Then this also will be 2, 3, 4. Then triangle 1 concurrent to triangle 2 in the sense. Even triangle 2 also will be concurrent to triangle 1. That is I am writing. Okay, triangle 1 concurrent to triangle 2. This implies 2 also will be concurrent to 1. Understand? Okay. Okay, what is meaning of this line? Triangle 2 concurrent to triangle 1. That what we can say, triangle 2, triangle 1 is there in the relation R. Why, sir? I told you if it is satisfied concurrent rule, surely that will be there in the R. So here T2 and T1 each other concurrent. So we can say it will be belongs to R. Understand? So what is the meaning actually? This is given that triangle 1 and triangle 2 I took in R. I took that it will be in R. We got an answer in the reverse portion also will be in R. So we got that T2 comma T1 also will be in R. Understand? If it is satisfied with this, what we can say? Actually, this is assumption. This is we are assumption. We got output like this. Then what we can say? This R is a symmetric. We can say. Therefore, R is symmetric. You can say. Therefore, R is symmetric relation. You can say. Understand? Right. Next topic. What is that? Transitive. I have to go. Next topic. Third one is what? Transitive. Okay, transitive in the sense what? See, again, this condition and all I have explained in the previous video. If you don't have idea, kindly you just see. Then, here, if two portion we should take, A1, comma A2 and A2, comma A3 should be belongs to R. Okay, these two things should be belongs to R. Then this implies outcome should be what? Except the common thing remaining will be there in the set. That is A1, comma A3 should belongs to R. Then we can say which is called the transitive. Understand? Here A1, A2 and A3 everything should be set A. For all A1, A2, A3 should be there in set A. Okay, set A, it's not visible. Okay, set A here. Understand? Right. So let's go to the answer. Right. What is the answer? First one. First we have to assume that T1, comma T2 and T2, comma T3 is belongs to R. What is meaning of this line? What is meaning of this line? This line meaning T1 concurrent to T2 and T2 concurrent to T3. This is the meaning. T1, T2 belongs to R. T2, T3 belongs to R. Then the meaning is these two things will be concurrent. These two things will be concurrent. Then surely what we can say, children, see here, triangle 1, triangle 2 and triangle 3. What is the meaning? Triangle 1 and 2 is a concurrent. Triangle 2 and 3 will be concurrent. Then surely 1 and 3 will be also concurrent. Concurrent means same shape, same size. 1 and 2 will be same size. 2 and 3 will be same size. Then surely 1 and 3 also will be same size. No change in it. So this implies triangle 1 concurrent to triangle 3 will be what? Concurrent. These things will be satisfied. What is the meaning of this? Triangle 1, comma triangle 3 will be in the relation. That is what they are telling here in the relation. So we have seen that two triangles are concurrent, that we can say which lies in the set R. Okay. So here T1, T3 concurrent. So we can say that which will be lies in the R. Relation R. So therefore, what you can say? R is transitive. R is transitive, you can say. Okay. So everything satisfied. See, R is a reflexive. Here R means, say R is a reflex. R is a reflexive. R is a symmetric. R is a transitive in the sense. Therefore, the given R means the given relation. What you can say? Is the equivalence relation. R is equivalence relation. All the three satisfied, then only we can say which is equivalence relation, otherwise not possible. Understand? And these things satisfied, so these things may come in 2 mark or 3 mark. You should be careful in this. Kindly you take a note, children. We'll go to the next question. We'll go to next question. Example number 3. See, example 2, we have seen that two triangles are concurrent. Here what I am going to see, L is what? L is what? Set of all lines. So L here, instead of triangle they given that set of all lines. So it will be line, either parallel line, perpendicular line, intersecting line, anything, skew line, anything will come in the plane. So R will be relation in a L. R is equal to given that R is equal to given that R is equal to given that line 1, line 2, such that line 1, line 2 in R na, that should satisfy one condition. What? Line 1 perpendicular to line 2. This should be satisfied. Two lines perpendicular, then we can say which is in relation R. That's it. Have you understand? Right. Show that R is a symmetric but neither reflexive nor transitive. It means R satisfying only symmetric, other two things not satisfying. That we have to prove. Understand? Right. So we'll go one by one. First, what they said, symmetric, that will take. Or else, if you want to go wise order wise, if you want to go, you can go first reflexive, and the definition order. First reflexive, next only symmetric. Okay. Next only what? Transitive. If you want to follow this order also, you can follow, not an issue. Understand? Right. So first we'll go in order wise, not an issue. Understand? First I will take that reflexive. So reflexive will take, listen children, reflexive in the sense what I said. See, A comma A should belongs to R. Here, for all A belongs to the A. A belongs to the A. This is the formula. Formula I have explained already in first video. Right. So we'll go to the answer. We'll go to the answer. Answer is what? So we have to take one line, line 1. The line 1 must be in the R. In the R. Whether it is possible or what, you have to check. If is it line 1, line 2 in the R, what is the meaning? Line 1 and line 1 is perpendicular to each other meaning. Same line cannot be perpendicular to each other. Same line can be parallel, but same line cannot be perpendicular to each other. So it never be belongs to R. It is does not belongs to R. What we have to say? Does not belongs to R. Since same line never perpendicular to itself. Same line never perpendicular to itself. That is you want to know. Understand? It's not perpendicular to itself. Right. So that what we can say, R is not reflexive. R is not reflexive. Understand? Right. Now we'll go to the second point, symmetric. Symmetric will take, symmetric in the sense condition first. What is the condition for the symmetric? A1 comma A2 belongs to R and their reverse portion also should be in R. That means A2 comma A1 also should belongs to R for all A1 comma A2 belongs to set A. This is the thing should be set. This is the formula we have explained already. Now we'll see the answer, children. Now we'll see the answer. See, two line you should take. Two line. First condition, two line you should take. So if L1, L2 I'm taking belongs to R. What is the meaning L1, L2 belongs to R? It means L1 perpendicular to L2. L1 perpendicular to L2. You can draw a diagram. Line 1, this is line 1. Perpendicular to line 2. Line 1 perpendicular to line 2. Okay. Perpendicular to line 2. Right. See, line 1 perpendicular to line 2. The same thing we can say line 2 perpendicular to line 1. Not an issue. That is, we can say line 2 perpendicular to line 1 we can say. Not an issue. Same meaning. It doesn't change. Then, this, what is the meaning of that line? See, L1 comma L2 belongs to R. We can say L1 perpendicular L2. Now, L2 perpendicular L1, that we can say that L2 comma L1 belongs to R. then the definition is satisfied. I assumed L1 comma L2 in R, the reverse portion I got in the R. Then what we can say? Then R is symmetric. Then R is what we can say? Symmetric we can say. Understand? Right. Third point, transitive will check. Transitive, first have you remember? Transitive in the sense A1 comma A2 and you take, and is better. And A2 comma A3 should be belongs to R. These two things we have to assume. First, these two will be in R. This implies A1 comma A3 belongs to R for all A1, A2 and A3 should be there in the set A. It's a A set. A set. All A1, A2, A3 should be there in the A set. So this is the formula should be satisfied. Understand? Right. We'll check this whether it's satisfying or not. Okay. We'll check this whether it's satisfying or not. First we have to take L1, L2 and L2, L3 should be belongs to R. Very important. L1 comma L2 if you take, the ending only should be beginning of the next pair. That is the condition we are using. L2 should be starting of the next. Understand? Like that I assumed. What is the meaning of this line? L1 perpendicular to L2 and L2 perpendicular to L3 is the meaning. That means we have a two line. L1 we have, L2 we have, both perpendicular to L3. L3 perpendicular to L1, L2 perpendicular to L3. Have you noticed? But here L1 perpendicular to L2. Wait, I will change the diagram then. I will change the diagram. L1 perpendicular to L2 as per the first. L1 perpendicular to L2. Next, L2 perpendicular to L3. Then L3 will be down. Okay, L2 perpendicular to L3. That is the diagram. Just for understanding purpose, I'm giving this. Now, whether L1 and L3 will be perpendicular. That you see. Whether L1 and L3 will be perpendicular. No. These things will be parallel. So that this implies L1 parallel to the L3 I'm getting. L1 parallel to the L3. If it is perpendicular, then only it will be belongs to R. But it is parallel. How we can say it is? So, that is, what is the meaning of that? L1 comma L3 does not belongs to R. Since this is parallel, I am telling does not belongs to R. Understand? So that, therefore, R is not transitive. R is not transitive. So we got here not reflexive, not transitive. That is they asked to show. Neither reflexive nor transitive, but it should be symmetric. That is they asked to show. We got it. Then hence R is symmetric. R is symmetric, but neither reflexive nor transitive. Okay, nor transitive. That's it. Hence, we have done a proof. Understand? Take a note, children. We'll go to the next. Next, example number 4. Example number 4, show that relation R, set A is given. Here, set A is given that 1, 2, 3. And R is given that here 1 comma 1, 2 comma 2, 3 comma 3, 1 comma 2, 2 comma 3, it's given. Okay, what we have to say, it's reflexive but neither symmetric nor transitive. Okay, it's satisfying only symmetric, other two not satisfying. That is we have to say. Understand? Right. Let's go now, children. Right. So first you will check that reflexive. So reflexive formula what? If A comma A belongs to R, for all A belongs to the A. This is the formula. Okay. Now see children, for all, see I have given with the example, all the terms in a A should be satisfying this condition. Suppose 1 is there na, 1 comma 1 should be there. 2 is there na, 2 comma 2 should be there. Next element 3 mean 3 comma 3 should be there. It's satisfying all the thing. Then what we can say, what is that here? You can write that 1 comma 1, 2 comma 2. We have just less count, not an issue. Belongs to R. Then R is reflexive. Why I am telling R is reflexive? For all 1 comma 2 comma 3 belongs to A. For all those things we have A comma A form, so that which is a reflexive. Understand? Right. Second is what? Symmetric. Symmetric in the sense we have a condition. First A1 comma A2 belongs to R. This implies reverse portion should be also belongs to R. Here for all A1 comma A2 belongs to the A. Understand? See children, relation R you take, it should be satisfying this. First 1 comma 1 reverse will be there. 2 comma 2 reverse will be there. 3 comma 3 means what? If you change also, it will change also 1 comma 1. If you send a 2 here, 2 it will become then same. So change also. But here 1 comma 2 if you take, if you change this what? 2 comma 1. 2 comma 1 not in R. So not a symmetry. That's it. So which is not there, that you take. Even 2 comma 3 also you can take. 2 comma 3 is there. 3 comma 2 we don't have. So not a symmetry. So what do you do? If 1 comma 2 you take. 1 comma 2 belongs to R, but 2 comma 1 does not belongs to R. So what you will say? Not a symmetry. That's it. Any one not satisfying also we have to say not a symmetry. Okay. So that therefore R is not symmetric. Understand? That's it. Next we'll go to the what? Transitive. Third one transitive will go. Transitive, you should remember the conditions. If A1 comma A2 and A2 comma A3 should belongs to R, this implies A1 comma A3 also belongs to R. Here for all A1 comma A2 comma A3 belongs to the set A. This is should be satisfied. Understand? Right. Now we will see the conditions whether it's satisfying or not. First you take anything. 1 comma 1 if you take, starting with the 1 it is there, which is not that you check. Suppose 1, this itself will take. Okay, if 1 comma 2 and see ending number 2, starting should be 2. So 2 comma 3 you can take, not an issue. 2 comma 3 belongs to R. This implies common number you should leave. 2 if you leave, 1 comma 3 should be lies. It is there here 1 comma 3. No. Then what we can say? This implies I'll give here. This implies 1 comma 3 also should be belongs to R. Then only this is transitive. But 1 comma 3 it's not there. So you have to give not a belongs to R. Understand? Then therefore R is not transitive. Okay. Not transitive in the sense for all the thing we have to check, which is not that you can write, not an issue. For everything you have to check here also. Understand? Right. This is the important. That's it. So hence R is what? R is reflexive. R is reflexive, but neither symmetric nor transitive. Understand children? Right, that's it ma, ends proved. One more thing about the transitive you have to learn. One more thing about transitive you have to learn. Suppose no terms for checking transitive. For example, this you just take a notes, then I will tell you. Suppose, see, no term. Here we have a term, two terms we had. Transitive in the sense, we need two term to check. Am I right? This two term, suppose not there in R. R, one term is there, sir, one term is not there. Also, you should say transitive. See, what is the condition? Suppose R is equal to 1, 2 only we have. Just 1, 2 only. No other element we don't have. Only one term we have. Then transitive, how you will check? Transitive, how you will check? It's not reflexive, not a symmetric. But why I am telling not a symmetric? Symmetric, one element should be there, we can check. Here directly should be there, the same thing. But in the transitive, two terms should be there. Then only third term you should check. But here only one term. Second term we don't have. So that if you face such question, you have to say this is transitive. You have to say this is transitive. Why, sir? There is no term to check, I'm right. Then there is no term to check the proper condition. It's not our mistake. Then we have to accept it. This is a true. This is a true you should accept. Understand? And one more thing you can take a notes. Every singleton set also transitive. Okay, every singleton set. Every singleton set is also transitive. This is one of the important, they may ask in JEE question also, very one of the important note. Okay, every singleton set, see in the relation if you have only one term there, that is singleton. Singleton means what? Only one term. One term is called singleton. So singleton element, singleton relation or singleton set you can say it is transitive. One more example. Suppose R is equal to, I have 1, 2. Very important, listen. 1, 2 is there. Starting with 2, it should be there one more element. But I don't have starting with 2. I have starting with 3. So what you will do? This is also transitive. Why? 1, 2 I have. Starting with 2 I don't have element. Starting with 2 I don't have element. So what you can say? This is first term. This is first term. Second term we don't have. So what you can say? This is also transitive. Okay. So it's not have a term to check transitive condition, that you have to say surely transitive. Understand? Very important note this is. They may ask in competitive exams also these things, very important. Understand, children? Right. The continuation means other examples I will give in next video, children. Okay. If you like this video, kindly share to your friends and subscribe the channel, like the video. Thank you, children. We'll meet in the next video. Thank you. Bye.